Good morning, all. Today we will study the concept of implicit and explicit functions. While studying the physics, on many a number of occasions we come across the situation that we have a certain function f of the two independent variables, say x and y, is equated to 0. So, in such cases, it is possible for us to obtain dy by dx depending on whether in the given function it is possible for us to separate the two variables, say x and y, from one another or not. There are certain functions in which we can express y as completely function of x, or in other words we can say that x and y are completely separated, completely isolated from one another, and such a function is called as the explicit function. So y can be said to be the explicit function of x, or x can be expressed in terms of y. So x is said to be explicit function of y. For example, if we consider the equation of a straight line, the simplest equation, say y equal to mx plus c. Here on the left hand side of this equality sign we have the variable y, and to the right side of this equality sign we have the variable x. So the terms of x and y, since are separated from one another completely, such a function is said to be an explicit function. And if we have such an explicit function, here y is expressed in terms of x. Similarly, we can express x as certain function of y. So this will be y minus c upon m. So here x is expressed in terms of y. So x and y are completely separated, completely isolated from one another. So such function is said to be an explicit function. And in case of explicit functions, it is very easy to determine the value of dy by dx. We can differentiate, say, y with respect to x. If we differentiate this expression y equal to mx plus c with respect to x, we get dy by dx is equal to m, or else we can differentiate x equal to y minus c upon m with respect to y to obtain dx by dy, and dx by dy will be equal to 1 upon m. So in case of such simple functions or explicit functions, it is very easy for us to obtain the dy by dx, differentiation of y with respect to x, or differentiation of x with respect to y. But on the other hand, we have some functions. Say, for example, the function we consider here is of the form, say, e raised to xy minus sine xy is equal to 0. So if we consider such a function, in such function, can it be possible for us to express y as completely function of x, or x as completely function of y? Or in other words, can it be possible for us to isolate x and y from one another in such cases? It is not possible, because the given function is very much complicated function. And in case of such complicated functions, it is not possible for us to isolate or to separate y and x from one another, and such a function is called as implicit function. So here we can call it as y is the implicit function of x, or x is said to be an implicit function of y. Now, if we have such implicit function, can it be possible for us to obtain the value of dy by dx in such implicit function, in case of such implicit functions, so let us see. If y is completely expressed in terms of x, easily we can obtain dy by dx. But in case of such complicated functions where y and x cannot be isolated, how to obtain dy by dx, let us see. Though even if it is not possible for us to isolate x and y from one another in case of implicit functions, still then we can obtain the expression for dy by dx. So let us see how to obtain the expression for dy by dx in case of such implicit functions. Here we are given that the function f, which is the function of two independent variables x and y, given to be equal to 0. And if fxy is equal to 0, this implies that df is equal to 0. Since fxy is equal to 0, which implies that df is also equal to 0. Now, if we have the given function f, which is the function of say two independent variables x and y, we can obtain df by dx of such function. Differentiating f with respect to x, we get df by dx is equal to dou f by dou x into dx by dx plus dou f by dou y into dy by dx. So this is how we can obtain df by dx for the given function f, which is the function of two independent variables x and y, and the value of this function fxy is equated to 0. So here what will be dx by dx? Dx by dx will be 1. So we can express this relation as df by dx is equal to dou f by dou x plus dou f by dou y into dy by dx. So here what will be df by dx? Since fxy is equal to 0, df is also 0, and if df is 0, then this left hand side of this expression must be equal to 0. So since df by dx is equal to 0, df by dx is equal to 0, we can write this expression as dou f by dou x plus dou f by dou y into dy by dx is equal to 0. Or else we can express this relation as dou f by dou y into dy by dx is equal to minus dou f by dou x. So dou f by dou y into dy by dx is equal to minus dou f by dou x. And if we transfer this term dou f by dou y to the right hand side, we can write the expression for dy by dx is equal to minus of dou f by dou x divided by dou f by dou y. So in the given function, even if it is not possible for us to separate y from x or x from y, still then we can obtain the partial derivatives of this function f, that is dou f by dou x and dou f by dou y, and differentiating f partially with respect to x and y, we can, using those expressions for dou f by dou x and dou f by dou y, in this expression we can obtain the expression for dy by dx for such a function, such a complicated function in which though it is not possible for us to separate x and y from one another. So that is how we can obtain the expression for dy by dx. Here we can replace dy by dx by y dash and rewrite the expression as, say, dy by dx if is replaced by y dash or y prime, we can write this expression as do f by do x plus y prime do f by do y is equal to 0. So this is how we can obtain the expression for dy by dx in case of implicit functions. In case of implicit functions, we can obtain the expression for dy by dx. So let us see one example. The concept of this, how to obtain dy by dx in case of implicit functions, let us see with the help of one example. Say we are given the function if x cube plus 3x y square minus y cube is equal to 0. You are given the function f, which is the function of two variables x and y, expressed like this, and it is equated to 0. And if for such a function you are asked to show that the expression for dy by dx is equal to minus of x square plus y square divided by twice xy minus y square. You are asked to show that dy by dx is equal to minus of x square plus y square upon twice xy minus y square. That is what we want to prove. So here we have this expression f, function f of x and y. So let us first obtain the expressions for dou f by dou x and dou f by dou y. So differentiating this f, suppose f, which is the function of two independent variables x and y, is expressed as x cube plus 3xy square minus y cube, then we can differentiate f partially with respect to x to get dou f by dou x, and dou f by dou x will be equal to 3x square plus 3y square, or this will be equal to 3 into bracket x square plus y square. And differentiating f partially with respect to y, we get dou f by dou y. Differentiate of the first term with respect to y will be 0, and this will, second term will be 6xy minus 3y square, or this can be expressed as, if we take 3 common into bracket, it will be twice xy minus y square. So we have obtained the partial derivatives of the function f with respect to x and with respect to y for the given function. And knowing the expressions for dou f by dou x and dou f by dou y, now we can obtain the expression for dy by dx. We can use directly the formula for dy by dx. What is the expression for dy by dx we have seen just now? Dy by dx is expressed as minus of dou f by dou x divided by dou f by dou y. And using these expressions for dou f by dou x and dou f by dou y, here we get minus of dou f by dou x is 3 into bracket x square plus y square divided by dou f by dou y is 3 into bracket twice xy minus y square. So this 3 gets cancelled. So we get the expression for dy by dx as minus of numerator terms are x square plus y square and denominator terms are twice xy minus y square. So that is what we are asked to prove. So in case of such functions, though it is not possible for us to isolate x and y from one another, still then we can obtain dy by dx for such a function by using this expression for dy by dx given by dy by dx is equal to minus of dou f by dou x and divided by dou f by dou y. So that is about this concept of implicit and explicit functions. And the last point of this chapter, that is the conditions for maxima and minimas, that we'll study in next video.